into it, we were talking about the decision-based classifiers, and this was something which you basically comes at the last. Okay, what is it? A very simple thing of advantages, disadvantages, and of course the characteristics. So what do you have? First of all, what do you mean by, or what do you mean by decision tree, based classification? You are trying to classify a data by writing a decision tree. What is a decision tree? You are writing your decision in a format of a tree. Okay, what does it have? It will easily have one root and either two or more branches. Okay, two or more branches. If it is only two branches, you call it as two-way split or binary split. If it is having more than one branch, you call it as multi-way split. Right? Okay, if you think of something like, whether he or she has paid the fees, yes or no, binary split. You can have a multiple split also. How do you have a multiple split? Amount of fees paid, take out the range. Okay, take out the range, 50%, 50 to 70%, more than 70%, like that. Multi-way split also you can have. So for each and every decision-based thing, you can write a format of a tree. Okay, so what is this? Why you're trying to do this? You want to classify a data. So you should not forget that. We are talking about classification. Below that, we are talking about decision tree induction system. Below that, we are talking about all the things that you study. Okay, right from what is entropy, information gain. Before that, what is the different types of decision trees that you get. Based on what you get, all those things you learned. Okay, now we come across a point where you are talking about, okay, you studied so many things related to decision trees. Now let me tell you what is the advantages, disadvantages of it. Then let me start with learning about what are the characteristics of your decision tree. Then let me go into the next part, which is after leave decision tree for us. What is the other ways of doing classification? Okay, this is how you need to sum up everything. Okay, very important for you to sort of learn things. Okay, always see the PTL course, all those things are already open. I hope you people are getting used to it, or doing it, or you're taking the maximum utilization of it. Because again, I'm saying you don't just be limited to your college placements, and you'll understand this statement maybe right after your 7th sem. Okay, why and all I'm not be able to explicitly say, but you will understand the word meanings of these statements. Don't just limit yourself to your college based placements. Okay, you should be good enough to go outside and get placed. That can only come if you are resume or curriculum vitae, whatever you call it, is filled or is very good depth. It's having very good depth. Okay, courses, NPTEL related courses will give you that. Okay, make sure that utilizing it. Okay, so and also learning other things, so that it it brings in that weight to your resume. See what we studied? We studied classification. First we studied entire thing related to classification. And where did we study classification for the first time? We studied this classification for the very first time in data mining tasks. Okay, this was where it is. Where do you think it was? It was right in module 2, where you studied data mining, introduction to data mining. You came across something called as classification. In that classification, you studied only the basics of what is classification, that this and all. And now you see you are talking about classification in depth, not in depth to some extent of whatever VTU has given. In that classification, you came across what is known as decision tree. Okay, very, very important topic of classification. The next thing you're going to see is rule-based classifier. So you're talking about some rules are going to come. So you can see very clearly here, you're talking about decision tree here. Decision tree based classification. Here you're talking about rule-based classification. Okay, and then the next thing, the last part, you're talking about Bayesian classifier. Now, who is this? What is basic Bayesian classifier? You're talking about some person called Bayesian. Okay, a Bayes, or rules that are given by him, and based on that you figure out what are the different types of classification, or not different types, what is the way of doing classification using Bayesian classification. Okay, or Bayesian classifiers to be precise. Okay, this is what you're going to learn. This is a summation of your entire module 4. Of course, you learned a lot of things here, and these two are going to learn in general. Okay, we are what is this and all, and then here also same. Here in-depth analysis of, not in-depth again, to some extent very good analysis of decision tree and a lot of things. Okay, there are other lot of things also in this which we are not studied, which is not there for your syllabus. Again, we'll see. Okay, once we sort of complete everything, we'll try to figure out some new extra things. Okay, or else if that is not also possible, when I'm sending you the PPT, I'll put that all those things in the PPT and send you. Okay, so that at least for your next semester it may be helpful. Anyway, the person who's going to come, he or she will be teaching you, but again some help. Okay, that's all. So this is the entire summary of where we are. Okay, so we are at the last part of this, so that before we move into these two. So based on decision tree induction system, what is the advantages that you have? Okay, first and foremost thing is it's inexpensive to construct. You need to have data, very inexpensive to construct, extremely fast at classifying unknown records. Okay, you can classify the records in a very efficient way, faster way. Next, easy to interpret for small size trees. So obviously you can see this point and you can make out a very simple thing that for a small size trees, you can write a decision tree very easily. But for what happens to the big one? For a big one, it is tough. Okay, that is what you see in the disadvantage here. Space of possible decision tree is exponentially large. Okay, what is the meaning of that? If the data is more, okay, if the data set is more, then to build a decision tree, or if the data set has multiple linkages, then to build a decision tree is very tough. Okay, not very tough. Okay, then robust to noise. What's the meaning of noise? Noise, you have already learned about noise and all again in module 2. What's the meaning of noise? Any unwanted data. Unwanted data in your data, okay, in your data set is known as noise. It is robust to noise. What is the meaning of that? That you are taking out the noise very well. Okay, you are not including the noise in your decision tree. Why? Because you are going to go for each and every value. If there is some unwanted value there, you are going to take that away. You are not going to include that in your tree. Because you know what is the thing with regard to tree. You are only going to take what is relevant to that root node, to that parent node. Okay, so like that, robust to your noise, especially when methods avoid overfitting or employed. Okay, can easily handle redundant or irrelevant attributes. Now, irrelevant attributes is nothing but your noise. Redundant is not noise, but you can call it as noise because it's coming again. Okay, so it's a repeated data. Okay, redundant means repeated data. So again, will you include repeated data in your decision tree? No. Okay, we are going to include only data only once, either as a parent node or a root node or a child node. Okay, only once, not more than that. Okay, what is the next thing? Okay, what is the disadvantages? Okay, see, again, I'm saying it is not just limited to whatever that's been given here. You can write your own way of advantages, your own way of disadvantages, but you should keep these points in mind. Okay, you have to keep these points in mind, and based on that you need to figure out. Based on seeing the marks, you should be able to write how many. Okay, if they have given advantages, disadvantages of decision tree based induction system or decision tree based classification, they have given say for 5 marks. Your mind should automatically think 2.5, 2.5. 2.5 means don't take 2.5. Let me write at least 4 advantages, 4 disadvantages. Okay, so that easily they will be able to give that 5 marks to me. Okay, like that you need to think always. Minimum 4. You can write more than that also. Okay, so let me go into the next part of it. Okay, what are disadvantages? Space of possible decision trees is exponentially large. If you want to include your decision tree in the the memory system, it is more. Okay, that is what they're trying to say. Space of possible decision tree is exponentially large. Number 2, writing decision tree for a very big data set is a tough task. Okay, number 2 over. Greedy approaches are often unable to find the best tree. What is the meaning of greedy approach? Greedy approach in very simple words mean that you start with a particular predefined set of rules and you keep on carrying with it. You are not going to change your strategy. You are going to go with the rules. That's what it's called as greedy approach. And what does greedy approach basically do? They try to figure out your optimal solution, maximal or minimum. Okay, all these things probably would have learned in your fourth sem. Okay, when you studied greedy approach, or maybe in third sem. Third sem it was not there. Okay, fourth sem only. Okay, you studied all these sort of things. So greedy approaches are often unable to find the best tree. Next, it does not take into account interaction between the attributes. So if there is an interaction between attributes, we generally don't do that. Okay, we don't really link a tree like this. Okay, let me show you like this. A tree. Think about a decision tree. Okay, do we link like this? You have a tree like this, maybe a thing like this. Okay, and you just think about it that attribute that you have it right here is having some sort of an interaction or having a little bit of data which is almost okay similar or same to. Okay, now do we link like this? Do we have a link like this? No, we don't do it. See, the very aspect of having a tree is to make sure that they are acyclic, right? A tree should be acyclic, otherwise you don't call it a tree, you call it a graph, you call it a loop. So it should be acyclic. So you don't really link this, even though they have some sort of a same attribute, okay, relations. You don't link it. Okay, now some people may again get that out. Okay, if it is having same attribute relation, why is it coming in a different set of thing? Maybe they are split based on a different criteria. Okay, they are split in a different criteria, but they have certain things, or majority of the things same. That's why it's called. You are following the greedy technique, which basically clearly says there are rules. Follow that rules. Split that tree like this. Okay, this is what is going to happen. So you are going to what you call as interaction between things. It is always a disadvantage. Okay, that's what it clearly says. Does not take into account interaction between your attributes. So each decision boundary involves a single attribute. Okay, that's very clear from when you write your decision tree itself. So when you write at the very last thing, okay, very last thing. So what is the meaning of what is in very simple words? What is the meaning of that? When you're going like this or like this data to go like this, you have what is known as a particular reason for it. Or if there is more than one also like this, to go like this, you have a particular reason. Okay, that is what they clearly say. The advantages, disadvantages. This is a classic of what you have it in your test book. The entire PPT is from test book. Okay, probably I'll be putting even more, a little bit more. Okay, when I'm sending it to you, always remember, see the marks based on that, create your advantages or disadvantages. Okay, so you are in almost in 6, you are at the end of 6 sem. Okay, these things should never be a problem. Okay, now let's go into the next part. Okay, the last part of it is called characteristics of your decision tree. Okay, which basically means you're talking about what is the decision tree characteristics. First of all, decision tree induction is non-parametric approach of building classification models. What is the meaning of that? What is the meaning of that? Very simple. It does not require any prior assumptions regarding the type of probability distributions. See, you don't have to have what is known as any prior data related to it. Okay, where do you think it's used? All those things, it's not at all used. You see a data. Okay, you see a data, based on that you will keep on rating the decision tree. There is no prior knowledge involved. There is no prior knowledge required. Okay, that's something that you got to know. Next, yeah, the probability distribution satisfied by class or other attributes. Okay, finding an optimal decision tree is a NP complete problem. Now this NP complete problem is something which probably you must be knowing. Okay, since you people have written, written an exam based on, ATC. There was NP based problem even in your DBMS, if I'm not wrong. Okay, so what is NP complete problem? What is the simplest way of talking about it? NP complete problem. What is NP first of all? NP is, you're talking about the computational complexity only related to you studied NP complexity right in fourth sem and NP based problems in your ATC. Lot of things. Okay, so what is that basically? Okay, what is that? Or what is an example for a NP complete based problem? No efficient solution algorithm has been found for this very clearly. Okay, many significant compression problems belong to this class. What is the example that you can have? Very simple example: traveling salesman problem. Okay, or the graph covering problem. I think you would have studied all this thing in your fourth sem. Okay, so that is with regard to NP. There are two things, right? NP hard problem, NP complete problem, and all. Okay, so what is N and P and all? Probably you must be knowing. Okay, P is set of problems. Okay, so what is P? NP problems that can be solved using what? Non-deterministic Turing machine. Okay, NP complete problems and all. So that they are talking about. Okay, finding an empty, optimal decision tree is an NP complete problem. In other words, they say the time complexity, okay, comes in terms of your NP complete problem. Techniques for developing or constructing decision tree are computationally inexpensive. Okay, see this? Computationally inexpensive, making it possible for quickly construct models even when the training set is very large. Okay, because it is computationally inexpensive, you can easily construct model based on the training set. Okay, now what's the next thing? The worst case complexity is with regard to big O of W. What is W? W is the maximum depth. What is big O? Probably you must be knowing big O again in fourth time only last year. Okay, by this time you would have studied all these things. Big O computations. Okay, big theta, big omega. Okay, so this comes in big O notations. Big O of W. W is, see, you in fourth sem maybe would have come across, what is it? Yeah, you would have come across of big O of N, where N would be representing your amount of input. Okay, here you are talking about big O of W. Where is W representing? W is representing your depth. Depth ka matlab, number of nodes that you have or the number of levels that you have. Okay, what's the next thing? Decision trees, especially smaller size trees, are relatively easy to interpret. Yeah, easy. Small ones are easy to interpret. Big ones, very tough. Okay, decision tree algorithms are quite robust to the presence of noise. Again, see what is this characteristics I'm talking about? I'm placing all the advantages, disadvantages in one place and I'm calling it as characteristics. New thing? No, same thing. Okay, next, the presence of redundant attributes. Okay, what's the meaning of redundant? Same old attributes. Does not adversely affect the accuracy of the decision trees. Why? Because we are not going to choose that only. Okay, we are not going to choose that only, because of which the accuracy see, the talking about accuracy, be careful. The word which you are going to use for a very many times called accuracy, especially in an XM, AI and machine learning. Okay, accuracy should be more. First you start with small accuracy, a little bit more later, a little bit more later. Like that, you keep on increasing your accuracy. Okay, presence of redundant attribute does not adversely affect your accuracy of decision tree. Okay, next, since most decision trees employ a top-down approach, we have learned almost top-down approach only. Okay, bottom up very unless and until, see, our brain is, or we are modeled to figure out everything in a top-down approach. Okay, generally it's very rare that you start drawing a tree from a bottom-up approach. Okay, have you even done like that? So it's drawing a tree like this. Okay, let me go with this, then I figure out this too, then like this. Maybe okay, if you are drawing something like a optimal prefix tree, something when whatever you're learnt in your third sem. Remember third sem, okay, long back, okay, optimal prefix tree. Or in fourth sem, you would have come across what is known as the Huffman tree. okay, of main code and all. That you'd have came across with regard to this. That you go with bottom-up approach or a heap. Okay, even heap has two down approach. Okay, top down and bottom up approach. So you go like this. Okay, then you figure out the next thing. Okay, again you have one more here. So you go with and keep on going like this. This is with regard to bottom up approach. But generally we go with tree which is top down approach. Okay, start from top, keep on drawing conclusions later below. Okay, so that's what they clearly say here. Okay, that you employ a top down approach, top down recursive partitioning approach. Number of records becomes smaller as we traverse down the tree. Very true. Okay, number of records always becomes smaller. That is our intention, to make sure that we have very less number of attributes right at the end. So at the leaf nodes, what you are going to do? The number of records may be too small to make it statistically significant decision. Okay, at the leaf node, that's why you call it as leaf nodes. That's why you call it as children. Children are not significant, parents are significant, root node is significant. Okay, about the representation of nodes. Okay, this is known as the data fragmentation problem. What is data fragmentation problem? Again, something which probably would have learned maybe in DBMS a little bit, or else you're going to learn it in data analytics later. Okay, see, I was seeing that open elective things which I think ma'am had sent, but I think those open electives is not for you if I'm not wrong. Okay, that's for those people who are coming across to CSC and ISC, so the other department guys. But you people has to study subjects which is given by other people, right? So it's maybe a subject related from civil or mechanical. It's EC. I doubt whether you go for EC and all. Generally civil, mechanical and all. Okay, or electrical. Electrical again, doubtly. Okay, these things only you learn, right? But see, think about it. People who come from EC or other backgrounds, they're going to study a lot of things. Especially one of the subject is data analytics. It's an open elective. So okay, so but again, it all depends whether they know it or not. If they take it as a more like, okay, let me write one subject, let me pass. If that is the intention, then they may not be able to study. Okay, yeah, fine. We'll see that later. Okay. Anyway, next one possible solution is disallow the further splitting when the number of records falls below a certain threshold. Have I kept any threshold here? No. Have we kept any threshold for figuring out any decision tree? No. Okay, those things will come. When you keep a threshold, like, okay, after these attributes, don't split, keep this itself, here itself. Okay, that is called as keeping a threshold. Why they want to keep a threshold? So that even the child nodes or the leaf nodes can be used to build some sort of a significant data or some sort of a significant rules. Okay, a subtree can be replicated multiple times in a decision tree. Okay, everyone knows that. So this is with regard to characteristics. There are even more characteristics. This is with all your textbooks. Okay. So the two approaches. One, you need to include what is there in textbook, and of course, we'll put some extra data. Okay. It's all from your textbook. That's very important. Now, this is with regard to entire thing is with regard to decision tree. The next thing, what you see now is based rule-based classifier. So there is some rule that is going to come through. Okay, rule that is going to come through, and what is the rule-based classifier? Very simple thing. Okay, to come across again with regard to this. Okay, I'm going to take a current affairs news. See, what is the thing that you have? What is rule-based? You will be having some sort of a rules here. How do you think the rules are formed? The rules are formed using two keywords, main two keywords. What are the keywords? Okay, somewhere way back in your school level, you would have come across, okay, or maybe in AD in third sem, or in even in DMS in third sem. Okay, you would have come across this rule that clearly says like this: if X, then Y. We are only knowing what is this if you are only knowing what is this, then in significant terms related to DMS, you can write like this. Okay, what do you call this? It's called conditional. What are the two words that really make up that? If and then. Okay, if and then. So based on these rules only, this rule-based classifier will be working based on these things only. So what is that? If Argentina wins, then I am happy. Okay, what are the most important thing? If Argentina wins, okay, then you have then I'm happy. This is how you split this entire sentence. Or if England loses, I am happy. Okay, or even more complex statements. Even more complex statements clearly says if. Okay, one more. If, so what is the next thing I'm going to do? If Argentina, be careful, and Italy win, then I am happy. Now you can see one important thing that you need to come across. There's a if statement very clearly, then there is a then statement very clearly. In between you have a multiple statements. What is multiple statements? Or a combination of a statement. Argentina and Italy both are combined. Okay, then you have what is known as the conclusion part of it. So all your rule-based classifier will be following this approach. Okay, so in the next 2-3 classes, you're going to learn a lot of things here. Now you can see what is the thing that you have. Classify the records by using the collection of if and then. Okay, if and then. Why? What is the example I took? I took the example with regard to sports, the very, very recent events in sports. I don't know how many of you sports fans, people who would have come across, I think, the last 2 days, they would have learned so many things. Okay, England has lost 2 places. One, of course, was your women's cricket, match, and of course, the last night thing, right? So, and before that, we had, this guy winning them. Okay, not this guy, this country winning it. Okay, you had people like this who really wanted to be a world champion who got it. Okay, and people who are tennis players, they would have seen one more person winning Wimbledon again. Not one more person, the person who's been winning it from a very, very long time. Okay, and has almost equal the number of records. Okay, the Grand Slam records. So lot of things, right? There were 4 events, last 2 days. Last 2 days or last 48, 48 hours, if you take into consideration, there were 3-4 very significant sporting events that happened. I don't know how many of you followed it. I hope everyone would have followed it. Okay, do get to know. Okay, what are things? Okay, so what are the things that we come across here? We are going to classify all the collections. See, again, it is classify. The word should not be going out of your mind. We are talking about classification only. So we are going to classify the data based on 2 things, if and then. Okay, if and then. So how do you think it will be? It will be written like this. What is this R representing? R representing your rule. R1, Y, R2, V, up to N. So R is nothing but your rule set. Okay, and all the other things are nothing but the rules, the conjunctions, the distinctions, everything that you're going to come across. Okay, you can see the condition. Condition is conjunctions of attributes. What is conjunctions? Combining. Conjunction, disjunction. Remember, long time. Should not forget all these terminologies. Conjunction, disjunction. Okay. Y is a class label, which basically means there is a rule. Okay, and because of that rule, you get this Y. That is what it clearly says. Okay, this left hand side of it. The left hand side is known as antecedent. Antecedent in literal terms also is known as something that is going to come before. Okay, something that is going to come before is known as antecedent. The later part of it, or the right hand side values of it, is known as consequent or consequence. Okay, consequence. You can think of that, very simple thing, right? I give you this example itself. If plays well, okay, then Wimbledon is his. Look into this statement clearly says, if plays well. This is what is known as your antecedent. Okay, because of this antecedent, what is the consequence? He wins this Wimbledon, or Wimbledon's is his. This is the consequence of it. Okay, very important to know what is the antecedent and what is your consequence. Okay, because lot of things we are going to use it many times in the next 1 or 2 sessions. Okay, so you can see very clearly rule, consequent, condition clearly says, okay, at this and this and this anything can be keep on going like that. The sentence can be keep on going. Okay, so one example that majority of it we are going to lose is with regard to this. Again, a data set is given with all the attributes. Okay, and what is the rules that are put in here? The rules are put in here. You can check very clearly how the rules are put in there. Okay, the rule 1 clearly says, what is the rule 1 clear? If gives birth is equal to no, where you have rules birth is equal to no, 1, 2, 3, 4 like that. See, you can have multiple rules based on the same attribute. Keep that in mind. You can have multiple rules, but all the rules should be satisfied to conclude something. See, rule 1 clearly says if gives birth is equal to no, and you can see this symbol that's called and if they can fly, that is equal to yes, then you conclude them as births. So again, I told you very clearly that a same attribute may have different rules, can be used for different rules. Same, you can see, check here, rule 2 gives birth is equal to no. Again, gives birth is equal to no, but the other point is changing. The other attribute, the other rule is changing. The other half of the rule is changing. Can fly is equal to yes, you conclude as births. Gives birth is equal to no. Will they live in water? Yes, you call them as fishes. Okay, next. See, again, I'm trying to classify data only. I'm not doing anything extra here. I'm trying to classify this entire data based on rules. Previously, what did I did? I tried to classify all these things based on decision trees. So difference need to be known. Next, you can see next, the next rule. If gives birth is equal to yes, and the blood type is equal to warm, what do you call it? Mammals. Okay. See, I think the same old example was used even to figure out what is decision tree. Okay. Here, of course, it's a bigger example, but you can see why you are talking about. Like this, you can make multiple numbers. See, you had something called mammals. Okay, did I write a rule for mammals? Yes. You have something called reptiles. Can I write a rule for my reptiles? Yes. Okay, clearly I can write. What is the thing I can write? If the blood type is equal to cold. Okay, and whether they give birth? No. Okay, will they fly? No. Will they live in water? No. But you should not see only one and thing, decide that. Okay, you need to check for other things also. Check for reptiles again. Again, it's the same thing here. Cold, no, no. Check here, cold, no, no, no. Okay, then again you check for reptiles here, cold, no, no. Here you're getting sometimes, they sometimes live in water. You think of a snake like python, okay, Indian rock python. They live both on land and in water. Okay, must be knowing what a rock python, right? Please Google if you don't know. Then if you think of other cobras, what do they do? Do they live in water? No, but they are reptiles. Okay, so you need to figure out a rule that clearly says that okay, this means it's reptile only. There should not be any discrepancy. There should not be any ambiguity. If you consider live in water, see, sometimes it is no, sometimes it is sometimes. Okay, again reptiles. So what is the two things you can easily take? Blood type is equal to cold. Okay, gives birth is equal to no, and can fly is equal to no. All three rules satisfied, you can easily conclude them as reptiles. Is there any reptile that has a warm blood? I don't think so. Okay, I don't think so. There's anything like that. Is there any reptile? I think there are few reptiles which gives birth directly. Okay, I think few of the snakes do that. So you can't take this. Okay, you can't basically take this. So, but you can take this. Can fly is equal to 0 or can fly is equal to no. So blood type is equal to, okay, can I write it here? Yes. I'll write like this, okay. If blood type is equal to, okay, blood type is equal to cold-blooded, very much cold-blooded, and can fly is equal to no, then you conclude them as, sorry, reptiles. Can any rules break this? Check. Blood type is equal to cold. You show me any reptile which is having warm blood type. Can any, can fly is equal to no. Show me any reptile that can fly. Okay. I think they used to have a, I'm talking about in dinosaurs times. They used to have, a reptiles that used to fly. Okay. People would have seen Jurassic Park somewhere, they would have come across that. Now, all those things are not there. We're not going to talk about any prehistoric times, only talking about things that are there. Okay. Anyway, people are making sure that almost all animals are getting vanished. Okay. This sort of continues, then we will be talking about even all the reptiles, like how we talk about dinosaurs. Okay. That should not happen. Okay. Protect the environment, protect your, nearby surroundings as much as possible. Okay, so these are the rules-based classifier you're going to think of. Okay, based on this, there's a lot of things that you're going to learn. Not a lot of things, the basic things, everything that is there, we are going to learn, and we are going to sort of look into this. Okay, next 2-3 session will be rule-based classifier only. It will be nice. Okay, because you already know decision tree,